Hello, welcome back PlayBASIC coders. Today we're going to be looking at a way of implementing a Z sorting technique into a scene full of custom objects. Custom, in this case here I'm drawing stars, but they could apply to anything. Let's run the example. So we've got the demo has two different modes. You control the modes with the Enter key. So in mode 0, we're drawing a scene full of perspectively correct circles. Now, circles that are closer to the camera should be drawn in front of everything else. And as you can see, if you look carefully, that's not the case, because they're drawn in creation order. If we turn Z sorting on, now we see that objects draw in correctly from back to front. So out of the 10,000 objects, we've got 3,700-ish that actually need to be rendered on screen to visualize the scene. Turn the mode off. It's much more obvious when you look at some of the nearby large objects as they move past. They should be in front of everything else. They're moving faster because prospectively they're closer to the camera. Turn Z buffering back on. Right on cue, a decent sized one went past. Let's look at the code. Spacebar to exit in this demo. We'll go through it. So our star structure, an array of stars. We're initializing the stars, giving each one a position, giving each one a Z depth. That's 100 units in front of the camera, our conceptual camera, to whatever the Z max depth value is, which is defined elsewhere. Each star has a size of 50, and we're giving them a random RGB color. Here I'm initializing the Z buffer, but we're not using that up front. So if we follow the rendering through, the render loop is just starts at the do loop, ends at the end here. This is the whole meat and potatoes of the program. This section here. So we're clearing the screen, locking the buffers, calling RenderStars and unlocking it, and then displaying information about what's happening. So how many objects are on screen, what render mode we are doing, and how many objects were drawn if we're doing Z buffering. Let's take a look at the render mode, the RenderStars function. We're passing in how many stars we want to actually update. Our projection, calculating the center of the screen, because everything's rendered relative to that central point. Are we in Z buffered mode or not? If we are, we reset the Z buffer. Then we start the main loop. We just check, is the star allocated? In this case, we don't really need that because we know that every star in this array is allocated, but they may not be in a real world case scenario. So first we grab its coordinates. We're grabbing its X position in 3D space, its Y position, and its distance from the camera. Projecting the X and Y into screen space. We're converting world space into screen space, and we're calculating the size of the object. Now what I was saying before, we could just do this once. Like, since we know that the Z, the depth of the star, and the camera's not moving, remember, so in this case we could just calculate it once, and then we wouldn't need to after that point. Now we have two different modes for the demo. We're either doing a render immediate, so we're rendering the circle as is. So because the stars they're not created in a pre-sorted state. Now you could do that. You could actually run through and create a whole set of stars, have all the Z's be mapped so they are starting from the far point and moving forward to the camera. You could absolutely do that. That's one way that you can actually avoid doing sorting at all. Anyway, when Z buffering mode's off, we just draw the circle to the screen. It gets drawn, the current color, the current screen position, whatever it happens to be. Here we're doing a clip to see if the thing is currently off the left hand side of the screen, we reset its position. A little bit of sleight of hand here, isn't it? We're resetting its position, we're calculating a new X, a new Y, and a new Z, and it just, next frame, it'll appear like it's coming from back onto the screen again. That's the render process for the standard scene. If Z buffering is on, what we have here is we're processing our characters in our scene, and then we're pushing them out to a stack once we know that that thing needs to be drawn. And that, well, a heap we'll call it, and that heap has all of the unique depths, and we're using a list between the current depth, and we're linking to each captured item in that scene. I'll go through it now. So if we have Z buffering mode on, rather than draw it immediately, we add this star to the Z buffer. We use its current screen position, size, color, and add these to the buffer. Let's have a look at the routine. We're doing a bit of a check up front. Is what depth is this star at? Do we need to actually store this thing because it might be too far away from the camera, or it might be behind the camera if it's negative? If that's okay, then we go through here and we do a clip on, is it actually going to be on screen? Because it may be in front of the camera but way off to the screens to the side. We don't want to waste time sorting things and rendering things that are not visible, so let's eject those ones. If it is on screen and it's a valid depth, what I'm doing here is I'm grabbing a current pointer to the Z buffer, which holds all of the captured items in their current state. Now, you don't really need to do this if you don't have generalized objects within your world, but I've done it this way to give you an idea of how that you can tackle adding different character types, all the different kinds of things, and then have the sorting handle the order of the scene. We'll go to the current offset. You can think of the Z buffer as one big chunk of memory, and when the Z buffer is reset, the current offset is set to the bottom of the memory, or the start of the memory, however you want to think of this thing, and we're just grabbing that there as this is the location we're going to write the data about this newly captured item. In this case it's going to be a star, but it could be something else, couldn't it? It could be you might have polygons, or you might have, who knows, sprites or circles or boxes or something more complicated than that if you wanted to. Here we've got a simple structure where we have each object that's captured has a screen space coordinate for X, Y, its size, and its color. So we're storing 4 things, and there's one more thing too, and that's a link. So if we step through here, when we know the character's on screen, we go cool. We grab a new pointer in the Z buffer cache, the heap. We write the data for this object. We're not going to draw it now. We can't really draw them till the end of the process. To manage the depths, we have a second buffer, and this is just an integer array where we're storing the pointers to any objects that are at that depth. So if I have a star and it's at a Z of 1000, we look inside the scene here. Depth would be an index of 1000. We're looking to see, are there any previous stars that were stored in this location? If it's 0, then previous star now equals 0. That's fine. There's no more after this. Then we set captured link, the current item we just added to the buffer. It points to the previous item, because we're forming a linked list of items at this depth. That's what we're doing. And then we just set at this depth, we set the caption item to be the head of the list. So if there's something already at this depth, the new thing we're adding gets inserted ahead of the other things. If you understand what I'm saying. And then we move, once we've added this to a little list, we just move the current pointer ahead past this structure size. And this is defined up here. So we've got our Z buffer stuff, which is just a bank in PB terms, a pointer to the bank, the raw size of this bank, and the current offset, which we just talked about before. So current offset is just the current position that we're writing data into the Z buffer as we call this add star to Z buffer function. All right, so when we process the stars, if we want them ordered, we can't do the rendering up front. So we cache this state, we store the information about the circle, and we add it to our Z buffer for drawing at the end. We zoom through here and do all of the circles. At the end of this, we call our render scene if we're in Z buffer mode. Let's go to here. What this does is it walks through this scene Z buffer, the scene Z depths array. It starts at the highest value, which conceptually is the highest depth. In other words, these are items that are the furthest away from the camera. We go, all right, is there anything at this location? In other words, is this a pointer or is it just 0? If it's 0, that means there was nothing in this scene that was at this depth. And we can just ignore this and loop back around. So we're looping all the way down to 0. We're starting from max depth and going down to 0, stepping backwards. So if we run through here, we check the depth. If it's not 0, in other words, if it's anything but 0, we start a while loop. We declare this object pointer. We place our current integer into this object pointer. So now this object is a typed pointer. We're looking at a bit of memory that we can now address with our fields. We can just go, give me the X position, give me the Y position, the size, and the color, and we'll draw this circle. I've got a counter here for how many things actually were drawn on scene. That draws the first one. Now, what we have to do then is we grab the link of this current one that we're looking at, this object, and get the object that it points to. So to do that, I'm just grabbing the link, putting it in pointer, while I was jumping back to the top. If this is not 0, if it's 0, that's the end of the loop, no more. And if it's not 0, we just keep looping through and stepping through all of the items that were at this depth that they're in the chain. Once we're complete, the for loop moves on, and we keep moving down the Z values until we get to 0, and that's how you render the scene. I mean, the beauty about doing this kind of approach is we're effectively using this array. Well, not effectively. We are using this as a map. We're using the Z to look up where to go next. So we're actually bypassing any need for any manhandling of data. Most sorting algorithms, in sorts, your comparative sorts, you're doing things like skimming through, either dividing and conquering, or this kind of approach, whether it's like quicksort or merge sort, or these things. This is more like a radix sort. In this case here, if all of your objects in the scene are at unique Zs, you can literally sort the whole scene without any collisions whatsoever. So all the objects are inserted at their Z position and added to the heap, which we then read that data back at the end to draw out the scene well, in painters, aren't we? To draw from the furthest object up to the closest item. I mean, you could apply things like secondary logic there to work out, well, to clip objects in the foreground to background objects, that kind of stuff. In older versions of PB, that was actually quite beneficial if you bothered to do that, but it adds a layer of complexity. Anyway, I hope that's shed some light on this kind of approach. It's pretty powerful. We've got 10,000 things here. I mean, it's a lot of things. Let's bump it up, see how terrible this runs when we'll try it with 25,000. We won't get too crazy. I don't know how fast it's going to run. All right, so pretty good. So we've got 25,000 objects being processed, but roughly 8.9 thousand are making it through sorting and rendering. Let's push that a bit further. We'll double up again. Let's sort them. 15,000. Pretty good. All right, we'll try 100. 100,000. We've got 30,000 objects being sorted and rendered. Pretty good. It's much more obvious there that they're not stored in order. All right, let's push it harder. 500,000. This might crash. Let's sort it. There you go. One of the older demos I wrote actually clips a scene like this, and it maps circles to regions and then works out what part of the circle we need to draw, if anything. And that's very effective for scenes that have huge numbers of objects. Here we're actually just brute forcing it. We're just going, just render the whole thing for me, thanks. All right, one more. We'll try 1 million because I know you want to. Yeah, now we're probably at 2 frames a second now. But not bad for software rendering. You know, 1 million objects, 300,000. I don't know what the pixel count of that would be, but it'd be pretty high. By that I mean how much overdraw there is in the scene, by the way. With this many objects, each pixel would be drawn many, many times before you ever see it. Classically, that's just redundant. That's the kind of optimization you really should be making. But I mean, really, who's going to render 1 million circles? Yeah. Anyway, have fun. I'll see you next time, dudes.